So we're tackling day 19 of Adventive Code. Today we are doing linen layout. So we are given some kind of towels that we get for free, and they have a white, blue, black, and red and green stripes. So a towel GGR is green, green, and red, and so on. So we have various designs that we want to produce, and based on the towel patterns that we are given, we try to get those patterns. So we are given a list of available parts of the towel, and then we try to build up the towel. So the first one is blue, red, white, red, and then red, and so on. But some of them are impossible. So for example, UBWU is not possible because we don't have anything starting with U. So that makes it impossible. And our task today is to figure out how many of the patterns are possible and how many are not. So pretty simple problem, it seems, at least if we do it recursively. So we'll see if we can do that. So I will take the test data. Or actually, instead of recursion, we could do dynamic programming, maybe. Well, we'll see. So this is a big input. Well, not that huge, but still. And we will try to solve the problem. So first we need to read the problem itself. So first line will be patterns that are available. So input reader await, input reader read line async. And we will split that line by comma, and we will actually comma and space. So those are the patterns that we have. And then we will read an empty line. So that's the empty line. And now towels for, so while line await input reader read line is line towel. And we will count the ones that are possible. So possible count 0. So if it's possible to get the towel with the patterns, actually I'll store the patterns in a field there with string patterns just to use them. So we'll use the towel, and then we just find if it's possible. So private pool is possible string towel, and we need to figure out if we can build it up somehow. So one option would be to go through all the possible starts and then try the next ones and next ones and so on. So that would be a recursive solution. So yes, I guess that's what we can also do actually. So we can do something like a current towel. So if current equals towel, then we found a solution, and then we have to try different patterns. So for each of the patterns, we will try to add it up. So start equals current plus patterns I. So if towel starts with the new start, and the new start with the towel is possible, then we return true. Otherwise, we end up with false. So we basically try all the patterns, add them to the current start and test if it's possible, and then we return, and that should be it. That should be it basically. So maybe not as efficient solution, but it should be doable. At least it seems based on the input it could be doable. So we'll see. And so 19, let's run the test data, it's giving us 6. And let's try the big input. So we save here and we run with test data with input file. 267 is the result. That is correct. Okay, so we have the first part solved. Now the second part. So in the second part, we need to give them every possible option. So we need to figure out how many ways we can build up the towel. So for this one is 4 different ways, for this one 6 different ways. So all the possible ways we can do that. Right, so yeah, so this is just a little bit adjustment of our current solution. So as long as the recursion will not run for too long, it should be fine to just count the possible options. So count possible, and we will be add up number of different ways for each design. So we kind of add up plus equals, so we do possible count plus equals count possible towel, and then we return 1 when we find a way. So our count equals 0. We'll be returning, we'll be doing some kind of adjustment here. So if it starts with the new start, we add it to the count essentially, and we return count here as well. So yeah, that's it. Was a quick modification. We'll see if it's also performant enough, but this should be enough technically. So this data is giving us 16, which is okay. Now with the input file, and this is taking longer, of course, but will it be that long that it's going to be impossible to run? Well, it's taking its time. Okay. Well, it's taking a long time. I think we should get rid of it and maybe try something more efficient. So instead of this, let's do dynamic programming. It should be faster. So it's going to be int ways. So a new int towel length, and this array will store the number of ways we can get a specific index of the towel. So starting with index of 0, length plus 1 maybe. Yeah, that's better. So we will start with 1 way to get a length of 0. Now for length starting from 1 and until the end, we will see how we can build up the next part. So to get the length of 1, we need to take to get the length of 1, we need to try from, we need to add up the ways to get the previous ones to what we can add to get length of 1. So for previous length equals 0 to less than length. Yes, so previous length. And so if it's not possible to get the previous length, we get 0. And then this is probably very likely correct, but so we try to take the towel and cut it from the previous length to the current length and see if the thing that we cut out is one of the valid patterns. So hash set patterns, we can do hash set so that we can quickly search in the patterns. And we do new hash set string. So this way we kind of have the lookup faster. And we do previous length minus length. That should be okay. So contains current. If it contains the current one, we add the number of ways, the previous ways to the number of ways we can get the current length, basically. So that is that, and yeah, I think that's it. That should be all of it. So finally, when we're done, we get the number of ways we can get the full towel itself. So hopefully this will be okay and faster. And we have to, of course, make sure that it actually works. So let's see, that says data, we have the patterns there, that should be okay. And we count the possible ways. So now the first one should be doable. So like 1, right? I'm afraid about this one. So the towel is BRR, so there is one B. Should be able to find B and add it to the ways for line 0. Yeah, debugger is kind of bugging me. So less or equal. Oh, I see. That's the problem. I'm not continuing to the length itself, to the full length. It should be better. 16. That is okay. So let's see what happens with the input file. And we have, this overflow. So that's counted with longs. And it's gonna, okay. Yeah, debugger is not helping. So I cannot do hot reload this way. It's still overflowing. Okay, that's a big number then. So ulong. Let's make sure everything is ulong then. Okay, now we have something. So this is the number of ways we can do it. And that is correct. All right, so we have solved day 19 after some struggle with numbers, but definitely based on this huge number that we can see here, it's clear why the recursion didn't work and wouldn't work, because that would run for infinite amount of time. This is a too huge number to actually try all the ways, all the possible options. So this approach with dynamic programming is definitely more according to the problem size itself. So this is going to be more, this was a better solution, and we'll see if ChatGPT can also figure this out and go with dynamic programming instead of recursion there. So, okay, it was fun. Thank you for joining, and see you on the next day.